Hey there guys, welcome to this video. My name is Pushpinder Gill, and in this video we're going to be talking about SAT Math Subject Test Level 2. So this is the first section of this course that I'm actually starting, and we're going to be doing the whole comprehensive course on SAT Subject Test, right? And these videos are exclusively for SAT Math Subject Test Level 2. So I'm actually creating all the courses. We're going to be creating all of the courses like physics, biology, chemistry. And just to let you know that we as trainers, the trainers who are actually developing this course, we have taught more than 1,000 students just for these subject tests only. So we would just like to tell you that whatever we do here is the same thing we do in the classes. So that means we are giving you a comprehensive course here right on YouTube. And apart from that, many of our students, in fact, most of our students score above 750 because, anyone who is actually planning to write the subject test has to have a minimum level of mathematics or minimum level of subject knowledge. I think you should be aiming for at least a 700 plus in your subject test. Well, more on that in another video where I'll be talking only about what is a subject test and how do you approach it and what should be your score and all that. In this, I'm going to be starting on with functions, right? So I'm not starting out with linear functions or quadratic functions as yet. I'm just starting out on functions. There are so many things like inverse of a function, odd function, even function, defining functions, combining functions. There's so many things which are important before you even hit the different types of functions. So first of all, what I'm going to do is I'm going to start with telling you what is a function. So a function is something which has, it's actually a process which has the input of the number. So you input x and you get the output as y. So there are a set of input numbers and there are a set of output numbers. So let's suppose if I say that the function is that, you can actually define it in many different ways. So you can actually define a function. Let's suppose that function is f of x is equal to x plus 2. That means if the input is x, then the output is going to be equal to x plus 2. Now, if I want to show this function in terms of sets, so what I can do is I can actually say if I input 1, I will actually get 3 as the output. So you always have the input as the first letter and output as the second letter. So if I input 2, I will get the output as 4. If I input 3, I'll get the output as 5. So this is what a function is. A function is this is the input and this is the output. Now what you can do is you can actually plot this input and output on a graph as well. So what you can say is, let's suppose on the left hand side on the y-axis you always have the output, and on the x-axis you always have the input. So just like this case of f of x is equal to x plus 2, as you can see, when you input 0 you get the output as 2, so that is 1 point. If you input 1 you get the output as 3, that's another point. If you input negative 2 you get the output as 0, because if you input negative 2 you get the output as 0. So that means what is this? This is nothing but the same function shown to you graphically. This is nothing but f of x is equal to x plus 2. Now remember, we can also replace f of x completely with y. We can say that y is equal to x plus 2. So y is something which is generally denoted as the output. So I hope you're able to understand what I'm trying to say here. Let's move forward with this. So that is the kind of knowledge that you require for the subject test. So let's talk something about how do you define a function? When is a function a valid function? Now, a function is a valid function when it passes a test. So it has to pass a test. That test is known as the vertical line test. It says that on a function, let's suppose if I have this as a function, let's suppose y is equal to x plus 2. If this is a function, then if I draw any vertical line like this, that vertical line should pass the function only at a single point. So that is what then is the function is going then that's the only thing when the function is going to be valid. It's that if I draw any vertical line, the function that line has to pass only at a single point. Then only that function is going to be valid. That actually means that for every output, as you can clearly see, for every input, there has to be only one output. So is going to have every input is going to have an unique output. Fine. So I hope you're able to understand what I'm trying to say here. Now, if every input is going to have a unique output, that does not mean that every output will have a unique input. It's not the other way around, guys. Because let's suppose if I start with a function y is equal to x square. So y is equal to x square looks something like this. As you can see that this is a valid function it passes the vertical line test. However, let's suppose this output 5 is going to have two inputs associated to it, right? Let's suppose if I say the output 4, let's say y is equal to 4, can be equal to 2 square also, can be equal to negative 2 square also. So every input is going to have a unique output, that's a given. However, every output may have, so an output may have multiple inputs, right? So an output may have multiple inputs. So if I talk in terms of, let's say if I talk about in terms of sets, so let's suppose 1 comma 4 and 1 comma 2, this function will not be a valid function. Why? Because as you can see that a single input is associated with different outputs. So if I have inputs on this hand side and if I have outputs on the right hand side, and let's suppose these are the inputs and let's suppose these are the outputs, right? So there has to be only a single line on this side. There has to be only a single line on this side, right? However, there can be multiple lines like this. One input has to be associated with a single output. However, an output can be associated with multiple inputs. Then only that function is going to be a valid function. That is when it passes that vertical line test. So I hope you're able to understand what I'm trying to say here, guys. Let's move forward to the next part. Now let's talk about the domain and the range of the function. Now this can get really confusing. So let's go ahead and discuss that in detail. So a domain of the function are all the input numbers. So the set of all the input numbers, is known as the domain of the set, and set of all the output numbers, so set of all the output numbers is known as the range of the set, right? So set of all the input numbers is known as the domain of the set, and set of all the output numbers is going to be the range of the set. Let's say, for example, if I say y is equal to x square. Now this is something which is the output, and this is something which is known as the input, right? So that means input domain is all the possible values of x and range is all the possible values of y. So domain is all the input numbers, that means all the possible value of x, and range is the output numbers, which is all the possible values of y. So what are going to be all the possible values of x and y here? As y is equal to x square, as you know that y is something which will always be 0 or positive. That means y is always going to be equal to non-negative. So that means the range of this function is going to be all the numbers that are from 0 all the way till positive infinite. So that is going to be the range of the function. And what about the domain? Domain is something which is all the input numbers, and all the input numbers are going to be all the x values. And as you can see here that the function can take actually any x value. There is no limitation there. So the function can take any x values. That means the domain of the function is pretty much any number. I hope you're able to understand what I'm trying to say here. So this is how you define the domain and the range. So let's move forward to the next part, guys. All right. So let's talk about a function now. What do I mean by a function is actually a relation? So it says that a function is always a relationship. A function is always a relationship between x and y, between the input and the output. So a function is always a relationship between the input and the output. So a function can be x plus 2. A function can be x square plus 2. A function can be y square plus x square is 2. A function can be x cube plus y square into x square is 4. It can be anything, right? So it's basically a relationship which can be mathematically defined. So that is what a function is. A function is something which is a relationship which can be mathematically as well as geometrically defined. That is what a function is. Fine. So I hope you're able to understand what I'm trying to say here, guys. Let's move forward. Let's talk about composite functions. So let's suppose if we have two functions. Let's suppose f of x is one function and I say this is x plus 2. And I have another function that is g of x. Let's suppose that is actually equal to x plus 3. So I have these two functions. Now you can actually compositely define these functions. One of the functions would be the sum function that will be defined as f plus g of x, which is actually equal to f of x plus g of x, which would here in case would be x plus 2 plus x plus 3, which is 2x plus 5. Then the next type of function is known as the difference function. In the difference function, it's just the difference of the function f minus g of x is going to be equal to f of x minus g of x, which is in this case that is going to be x plus 2 minus x minus 3, which is going to be equal to negative 1. So it's a constant. The difference function in here is a constant. Another thing is you can have the product function. In the product function, you're going to have f into g dot x, which is actually going to be equal to f of x into g of x. I'm not going to use the example here, it's simple. The next is going to be the quotient function. So what is a quotient function? That is f over g of x, which is actually going to be equal to f of x over g of x. Now in this case, g of x should not be equal to 0 because as you know 1 over 0 will actually give you infinite. Another thing is that is known as the compositions of function. Now that is actually very important. I'm going to do that on a clean page. So what do you mean by composition of functions? So as if I say what is f this g, this degree g of x, that is going to be equal to f of g of x. Now if I say let's suppose f of x is equal to x plus 2 and g of x is equal to x plus 3, then what is going to be f of g of x? So what happens is the input of this f function is actually this function itself. So what you do is you start solving from the center. So start solving from the center, right? So what you do is you start solving for how do you write g of x? G of x something that can be written as x plus 3. So this is nothing but f of x plus 3. Now you treat this whole thing as x only. So what you're supposed to do, what is f of x? That is x plus 2. So this is x, that means this is x plus 2. So this is going to be equal to x plus 5. So this is how we do the composite functions. Let's suppose if I want to do g of f of x, then what I'll do is I'll first write f of x, which is going to be x plus 2. So that is going to be g of x plus 2. And then if I find g of this is going to be x plus 3. So that is going to be equal to x plus 3, which is again going to be equal to x plus 5. So I hope you're able to understand what I'm trying to say here, guys. Let's use a little bit of examples here. So let's suppose if I define a function f of x is equal to 3x minus 2 and I say g of x is equal to x square minus 4. Now what I want you to do is I want you to find out first of all f plus g of x. I want you to find out f minus g of x. I want you to find out f over g of x, and I want you to find out f of x into g of x, and I want you to find out yeah, so this is what I want you to find out. So go ahead and pause this video and try to find out all these values. Okay, so I hope you're able to solve this. So let's move forward and solve this out. So what is f plus g of x? F plus g of x is going to be f of x uh, plus g of x, which is actually going to be a quadratic function that is simply x squared plus 3x minus 6. So that's there. Second one is going to be equal to f of x minus g of x, that is 3x minus 2 minus x squared plus 4, which is again going to be a quadratic function like this. The next one is going to be equal to the division, which is f of x over g of x. So f of x is this and g of x is this. Now one thing that you have to understand, that x cannot be equal to positive 2 or negative 2, because this cannot be 0. The next thing is that it's a multiplication function in which you will say f of x into g of x. So that is simply going to be equal to 3x minus 2 into x squared minus 4. So I hope you're able to understand what I'm trying to say here, guys. Let's move forward to the next part. Okay, so now let's move forward to the next thing, that is inverse of a function. Now what do you mean by inverse of a function? So let's suppose if I have a function that says y is equal to x plus 2. Now inverse of a function would simply mean replace the x with y. So you replace the input with the output. So the inverse of the function will be x is equal to y plus 2. That is it. So y is equal to x minus 2 is going to be the inverse of this function. Now another thing that is important is that the inverse of a function, if I say f of x is equal to x plus 2, this is the inverse of this function would be represented as f raised to the power minus 1 of x is equal to x minus 2. And another thing that is important is that the f inverse of f of x is always equal to f of x is always equal to x, which is also true about f of f inverse of x. You want to put that to test? Let's do that. So what is f inverse of f of x? So f of x is nothing but x plus 2. So I'm going to write x plus 2 here. And similarly, what is f inverse of x plus 2? So what you're going to do is you're going to take this thing as x only. So that is going to be x plus 2 minus 2, which is going to be equal to x. So same thing you can find for f of f inverse of x. This is something which is true for all the functions. So for the functions which actually have their inverse, their inverse exists. So I hope you're able to understand what I'm trying to say here. Now understand another thing. And the inverse of a function, is not necessarily a function. Is not necessarily an function. It's very, very important. Let's say, for example, if I talk about a function y is equal to x squared. So y is equal to x squared looks like this. It passes the vertical test, right? But what is the inverse of this function? X is equal to y squared. X is equal to y squared is going to look like this. Now in here, as you can clearly see, it does not pass the vertical test. So that means this function does not exist. So that means it's not always true that inverse of a function will always be a function. It cannot be a function also. So I hope you're able to understand what I'm trying to say here, guys. Let's see some examples. Let's suppose if the function is f of x is equal to 3x plus 4. Let's say I want to find out the inverse of the function. So what I'm going to do is y is equal to 3x plus 4. I'm just going to replace x with y, and then I'm going to make y as the subject. So as you can clearly see, the inverse of this function is going to be equal to this. Right, so just replace x with y and make y as the subject. Fine. So I hope you're able to understand my point over here, guys. Let's move forward. Now let's say, for example, we have y is equal to x squared. What is the inverse of this function? Inverse of this function is x is equal to y squared and y is equal to square root of x. Right, so this is the inverse of this function. So I hope you're able to understand what I'm trying to say here, guys. Actually, it's going to be plus or minus square root of x. Okay, so that's there. And Let's move forward to the next one. Okay, I've already done that. Okay, so we have this question which says f of x, it says f of x is equal to 1 over x plus 4 minus 2. What do we have to do is we have to find the range of the function. Now, what is the range of the function? To find the range of the function, what do we have to do is we have to get. Now, here's one thing that I want to explain is I'm actually gonna use this here, that if I have a function, let's suppose f of x, and D is, let's say, the domain of the function, and R is, let's say, the range of the function. Then if I talk about the inverse, then the domain of inverse will actually be, the domain of inverse is actually going to be equal to the range of the function, and range of inverse is actually going to be equal to the domain of the function. Fine. So I hope you're able to understand what I'm trying to say here. The domain of the function is actually the range of the inverse, and range of the function is actually domain of the inverse. You can use it using this example. Let's suppose if I have a function y is equal to 1 over x, right? So if y is equal to, let's actually go ahead and use this example. Let's say it's actually x plus 2. Now, if I talk about the range of the function, so range of the function is all the output, sorry, if I, let's suppose I talk about the domain of the function. Domain of the function is all the possible input numbers. Now, as you can see over here, x cannot be equal to negative 2, isn't it? X is something that cannot be equal to negative 2, because 1 over negative 2 plus 2 will give you 1 over 0, which is something that does not exist. It's an infinite thing, right? It does not exist. Now, domain of the input is negative 2. Now, let's suppose I find the inverse. What do I do is I say x is equal to 1 over y plus 2. Now, here y can't take a value negative 2, because as you can clearly see, y cannot take a value negative 2. That means in the range, that is the value of output, y can't take a value negative 2. As you can clearly see that here x couldn't take a value negative 2, here y can't take a value negative 2. That means the domain of the function is equal to the range of its inverse, and it's the other way around as well, that is the range of the function is equal to the domain of its inverse. Now let's say I want to talk, let's talk about other thing also, that is what happens geometrically to the inverse. What happens geometrically? So let's suppose if I have a function f of x, right? F of x is equal to, let's say, is equal to x squared. So f of x squared looks like this. Now if 1 comma 1 is on the function, 2 comma x is equal to 2, y is equal to 4 is on the function, x is equal to 3, y is equal to 9 is on the function, x is equal to 4 and y is equal to 16 is on the function. Now if I find the inverse of this function, so this is y is equal to x squared. If I find the inverse of the function, which is going to be equal to x is equal to y squared. Now x is equal to 1, y is equal to 1 is going to be on the function. Y is equal to 2 and x is equal to 4 is going to be on the function. Y equal to 3 and x is equal to 9 is going to be on the function. Y is equal to 4 and x is equal to 16 is going to be on the function. That means from here I think you can easily make out that if a comma b is on function x, then b comma a will be on the inverse of the function. So if a comma b is on function x, then b comma a will be on the inverse of the function, which means I can say that f inverse of x geometrically is the reflection of f of x on the line y is equal to x. So that means this is the line y is equal to x, and I'm going to draw it again. So as you can see, this, let's say this is the line y is equal to x, and this is your function, that is x is equal to y squared. As you can clearly see that this is the reflection of this with the respect to this line, because that is what the reflection with respect to y is equal to x looks like. When you reflect something with respect to y is equal to x, when you reflect something with respect to this line, what happens is that a comma b gets shifted to b comma a on the line. You want to put that to one more test? Let's do that. Let's suppose if we have a function. Let's suppose that function is y is equal to x plus 2. So how is y is equal to x plus 2 going to look like? Y is equal to x plus 2 is going to look like is when you put x 0, y is 2, and when you put y 0, x is negative 2. This is how y is equal to x plus 2 looks like, and this is nothing but y is equal to x. Now, if you actually go ahead and draw the line, x is equal to y plus 2, that is the inverse of this function. So when you put x as 0, y is negative 2, and when you put y as 0, x is equal to 2. Right? So when you put y as 0, x is equal to 2, and this is going to be this line. As you can see that this line acts as a mirror for this line. So that means if 0 comma 2 is on this line, then 2 comma 0 is on this line. So that means f inverse of x is the reflection of the line f of x with respect to y is equal to x. So I hope you're able to understand my point over here. Now going back to the same question which was there, that is find the range of this. So range is the set of all the output values, right? So range is something which is the set of all the output values, that is set of all y values. Now here finding the y value is difficult, because as you can see x cannot be equal to negative 4. So if x cannot be equal to negative 4 here, if I find the inverse of the function, so here y is equal to 1 over x plus 4 minus 2. Now if x is equal to negative 4 is something which is actually okay. If I actually go ahead and find out the inverse of this, so if I replace x with y, so x is going to be equal to 1 over, so what I'm going to do is I'm actually going to write down the inverse in a different color. So x is equal to 1 over y plus 4 minus 2. So this is x plus 2 is equal to 1 over y plus 4. If I kind of reciprocate both the things, 1 over x plus 2 is equal to y plus 4. That means y is equal to 1 over x plus 2 minus 4. So for the inverse, x cannot be equal to negative 2, which means for the real function f of x, y cannot be equal to minus 2. So for the inverse, x cannot be equal to minus 2. However, for the real function, y cannot be equal to minus 2. That means all the values would be in the range apart from y not equal to being minus 2. So minus 2 is something which is not in the range of this function here. So I hope you're able to understand what I'm trying to say here. That is, the domain of this function is going to be equal to the range of the inverse, and the range of the function is going to be the domain of the inverse. So what I did here is I found out the inverse. This is the inverse, and x cannot be negative 2 in the inverse. That means y cannot be negative 2 in the real function. So I hope you're able to understand what I'm trying to say here. Let's move forward to the next one. So this says y is equal to 3x plus 2. Then what do I have to do is I just have to find the inverse. In that inverse, x is going to be equal to 3y plus 2. That means 3y is going to be equal to x minus 2, and y is going to be equal to x minus 2 over 3. That's easy, right? So you just found the inverse. So I hope you're able to understand what I'm trying to say here, guys. Let's move forward to the next part. Okay, so this I've already stated that inverse of a function is not necessarily not necessarily a function. So I've already talked about that. Now let's talk about what do you mean by an odd function. So by definition, an odd function is a function where f of minus x is actually equal to f of x. That is the definition way of saying this. But what do you mean by this? What is the meaning? It says that, an odd function is f of minus x is equal to minus of f of x. I'm really sorry. That is something which is known as an odd function. But what is the meaning of this? Why is this? What is this? Now in this, I would want to say that if you have a function like this, whatever is going on here should go on in here, right? That is what an odd function is. It says that whatever is going on here should go on here. Let's suppose if I want to talk about a function, let's suppose y is equal to x to the power 3. Now if y is equal to x to the power 3, if x, what is the value of f of 1? F of 1 is actually going to be 1. And what is going to be the value of f of minus 1? F of minus 1 is going to be minus 1. And as you can clearly see, f of 1 is equal to negative of f of minus 1. Right? So that means if you kind of reflect this function with respect to x axis, what happens, this function becomes the negative of itself. This is something which is not symmetric with respect to x axis. What is symmetric with respect to x axis? Let's suppose this function is going to be symmetric with respect to x axis. As you can clearly see here, that in this function, which is actually not a function, in this diagram, whatever is on the top is same as on the bottom also. Whatever is on the top is same as on the bottom also. But odd function is not like that. Odd function says that f of minus x is going to be equal to negative of f of x. That means as soon as I make my input negative, my function will become negative. Right? I hope you're able to understand what I'm trying to say here. The proper definition of an odd function is that the proper definition of an odd function is that f of minus x is equal to negative of f of x. So all the functions like y is equal to x cube. Now why did we call it an odd function? Because all the functions y is equal to x cube, y is equal to x to the power 5, x to the power 7, basically y is equal to x to the power n, where n is odd. All these functions are odd functions. Let's suppose y is equal to x. How does y is equal to x looks like? Y is equal to x looks like this. This is reciprocated here, not here, not here. That means this is an odd function. That means here f of x is this, and f of negative x is this. So as you can clearly see here, f of negative x is equal to negative of f of x. Just for the example here, f of 2 is 2 and f of negative 2 is negative 2. So as you can clearly see, f of negative 2 is negative of f of 2. So this is something what we call as odd functions, right? Now, the next type of functions that I'm going to explain are even functions. In even functions, what happens is f of negative x is equal to f of x. These functions are symmetric. These functions are symmetric with respect to y-axis. These functions are symmetric with respect to y-axis. That means whatever goes on this side, exactly the same thing goes on this side. Let's say, for example, if I say y is equal to x square. Now, if I say y is equal to x square, as you can see that whatever is going on this side, the same thing is going on this side. Because the meaning is that if you replace x with negative x, the function will not change. So that is actually a definition. If you replace x with negative x, the function will not change. That is something which is known as an even function. So if I say y is equal to x square, the function is this. When I say y is equal to negative x square, still the function is y is equal to x square. That means this is something which is an even function. So I'm going to summarize the even and odd function part, right? So what I'm going to do is I'm going to write down all the odd function here and even function here. So in odd functions, f of minus x is equal to minus of f of x, and in an even function, f of minus x is equal to f of x. Here, geometrically, it means, definition wise, it means that if you replace x with negative x, the function will become negative. The function will change. Here, what happens is that if you replace x with negative x, the function will not change. Here the function is not symmetric with respect to y-axis. If the function is here like this, it will be here like this. If the function is here like this, it would be here like this. Here the function is symmetric with respect to y-axis. If it's here like this, it would be here like this. So let's go ahead and do some questions based on this, right? So what I'm going to do is I've actually collected some questions based on what we have learned today, and you just go ahead and solve these questions all by yourself, and then I'm going to be showing you the explanation. Okay. So let's go ahead and do this question, guys. So why don't you go ahead and try this question out by yourself? Okay. So this question says that if 3, comma 2, 4, comma 2, 3, comma 1, and 7, comma 1, 2, comma 3 is to be a function, which of the following must be removed from the set? Now from here you can clearly see the function has to pass the vertical line test. The vertical line test says that every input is going to have an unique output. So let's write all the inputs 3, 4, 3, 7, 2, and let's write all the outputs 2, 2, 1, 1, 3. As you can see, 3 is associated with 2, 4 is associated with 2, 3 is associated. Okay, what I'm going to do is let me rewrite it because I don't need to write them again and again. So the only inputs are 3, 4, 7, and 2, and the only outputs are 2, 1, and 3. So as you can see, 3 is associated with 2, 4 is associated with 2, which is fine. 3 is associated with 1, that's a bad thing. 7 is associated with 1, and 2 is associated with 3. As you can see, 3 is associated with two numbers, which is not possible. It shouldn't happen because one input it should be associated with a single output. So what do I have to do is I have to remove which one of the following has to be removed from the set. I'm really sorry, this has to be none of the above. So from here it has to be 3 comma 2 because one of them has to be removed, so it has to be 3 comma 2, which is going to be my answer. So I hope you're able to understand my point over here, guys. Now go ahead and try the next part. So this question says that which of the following functions is neither odd nor even? So what are functions which are neither nor odd nor even? So those are the functions where f of x is actually going to be equal to not equal to f of negative x or not equal to f of x either. So they're going to be neither of them. So I'm going to start from these three answer options because I don't really want to actually get into these three. So I'm going to start with, let's say, answer option C first. So y is equal to x cubed minus 1. So if I replace x as negative x, so this is nothing but which is f of x. So what is going to be f of negative x? X of negative x is going to be equal to negative x cubed minus 1, which is actually going to be equal to negative x cubed minus 1. Now, is that equal to f of x? No. Is that equal to negative of f of x? No. Because negative of f of x will actually be equal to negative of x cubed minus 1. That should be equal to negative of x cubed plus 1. And this is negative of x cubed minus 1. This and this are not equal, which means this is something which is neither an even function nor an odd function. Fine. So you're able to understand what I'm trying to say here. What you can do is you can plug in and eliminate also. You can say what is f of 2 here? F of 2 is 2 cubed minus 1, that is 7. And what is f of minus 2? F of minus 2 is again negative 2 cubed minus 1, which is actually equal to negative 8 minus 1, which is negative 9. Is 7 equal to negative 9? No. Is negative 7 equal to negative 9? No. That means this is a function which is neither odd nor even. And you can clearly see this is an even function. And you can clearly see this is an odd function. I don't want to get into these two. So answer option C is going to be my answer. Let's move forward to the next one. So now let's go ahead and do this question here. Now first of all, I actually want to show you a real quick technique how to find out whether a function is an odd function or it's an even function. If you want to check out whether a function is an even function, just replace x with negative x. Just replace x with negative x. If the function does not change, then that function is an even function. Similarly, to check out whether a function is an odd function, replace x with negative x and replace y with negative y. If the function does not change, then again this function would be an odd function. So if for an even function, replace x with negative x. If the function does not change, it's an even function. For an odd function, replace x with negative x and y with negative y. Because if, let's suppose y is equal to x cube is an odd function. If I replace x with negative x, it becomes negative x cube. Now this is supposed to be equal to negative of y for it to be an odd function. Is that it? Well, yes, it is equal to that, because in this here minus y cube will become minus x cube, y and y will cancel. The function has not changed at all, which means yes, this function is an odd function. So here in the first one, if I replace x with negative x, the function is still x square plus y square is equal to 1. If I replace y with negative y and x with negative x, still the function remains the same. That means this is an even function as well as odd function. As you can clearly see, this is a circle. So a circle is symmetric with respect to all four axes. That means it's a function which is symmetric. The second one is here also, even if I replace x with negative x and y with negative y, the function will remain the same. That means you can clearly see that this is something which is even as well as odd. And the third one over here, if I replace x with negative x, the function will change. This is not equal to this. If x is equal to 0, then it's fine. But if x is equal to 1, 2 or 3 or negative 1 or negative 2 or negative 3, the function will change. That means this is something which is not an even function. That means these two, that is 1 and 2, are an even function as well as an odd function. So I hope you're able to understand my point over here, guys. Let's move forward to the next one. So the next one says, again, which of the following relations are odd? How are you going to check whether this relation is odd? You're going to replace x with negative x and y with negative y. Now here, if I replace y with negative y, the function becomes negative y is equal to 2. That means the function becomes y is equal to negative 2. That means the function has changed. That means this is not an odd function. Let's check this one. If I replace y with negative y and x with negative x, the function remains y is equal to x only. That means this is something which is an odd function. Here, I think in the previous example we did that. If I replace x with negative x and y with negative y, the function is going to remain the same, because negative x square and negative y square is going to give you x square plus y square only. That means it's 2 and 3. So I hope you're able to understand what I'm trying to say here, guys. I think it should be getting pretty easy for you now. Let's move forward to the next one. This one, I think it's the same question. No, it says which of the following relations are even. Now here, if I replace x with negative x, the function remains the same because there is no x. This is an even function. Now what is y is equal to 2? This is y is equal to 2. As you can clearly see, it's symmetric with respect to y-axis. So this is something which is an even function. What about y is equal to x? Now if I replace x with negative x, the function becomes this. So that means the function has changed. If the function has changed, that means this is not an even function. This is something which is an even function. We have established it so many times. So the answer is 1 and 3. So I hope you're able to understand what I'm trying to say here, guys. Let's move forward to the next one. Now the question here says that which of the following could represent the equation of the inverse of the graph. So first of all, we'll try to get the equation of this graph. Now equation of this graph is going to be equal to y is equal to mx plus c. From the graph, so we're going to be doing the linear functions in the next class. However, I think you should know this is something which is the slope of the line, and this is something which is the y-intercept of the line. That is the point on the line when it cuts the y-axis. So what is going to be the value of c? This is going to be the value of c, which is equal to 1. That means c is equal to 1, and the value of slope m is going to be equal to the y-intercept over the x-intercept, isn't it? So the slope of this line is going to be equal to 1 over 1, right? So which is actually going to be equal to 1 again. So that means the slope of this line is actually equal to 1. You can also calculate the slope using the slopes intercept formula. This point is x is equal to 0, y is equal to so this is x is equal to 0, y is equal to 1, and this is x is equal to negative 1, y is equal to 0. So the slope is going to be y2 minus y1, that is this, over x2 minus x1, which is x2 minus x1, which is going to be equal to 1 over 1, that is 1. So the slope is 1, and so that means the equation becomes y is equal to x plus 1. And what is going to be the equation of the inverse? So the inverse is going to be equal to x is equal to y plus 1. Okay, it's a which of the following could be question. So that means this is not definitely one. It can be anything else also. So what I'm going to do is I'm actually going to explain to you what happens to the inverse of a linear function. What happens to the inverse? So the inverse becomes x is equal to yx plus c. So x minus c is equal to yx, right? And that means, I'm sorry, it's not yx. That is wrong. Y is equal to mx plus c. It becomes x is equal to my plus c. That means x minus c is equal to my. That means y is equal to 1 over m into x minus c over m. Fine. So this is what happens to this function. Now as you can clearly see that the slope of, if the slope of this line is positive, the slope of this is also going to be positive, right? So that is there, and as you can clearly see, this line has a positive slope, so I can eliminate answer option 1. And if this intercept of this is going to be positive, the intercept of this is going to be negative. So as you can see that the intercept of this is positive, so that means our intercept should be negative. So I can eliminate this, I can eliminate this. And as you can clearly see, the intercept does not remain the same. It actually becomes gets divided by the slope. And you can clearly see here that intercept is remaining kind of the same here, which means my answer is option E. And you can clearly see that it gets divided by m, and it actually gets divided by m. So if I have an equation y is equal to mx plus c, then the equation of the inverse would be y is equal to x over e minus c over m. Or you can clearly see y is equal to x minus c over m. That is going to be the equation of the inverse. So I hope you're able to understand what I'm trying to say here, guys. Let's move forward to the next one. Now this one says that if f of x is equal to x, then inverse could be represented by what? Right? So he's saying if f of x is equal to x, then the inverse could be represented by which function? So the inverse is going to be, the function is y is equal to x. The inverse is going to be equal to x is equal to y. So that means the inverse will still be x, which means A is my answer. Pretty easy. I hope you're able to understand what I'm trying to say here, guys. Let's move forward to the next part. That is next question. He says y is equal to 2x minus 3. What is going to be the inverse? So that is going to be x is equal to 2y minus 3. X plus 3 is equal to 2y. And x plus 3 over 2 is equal to y, which is our answer option E. So I hope you're understanding this point over here, guys. Let's move forward to the next one. The next one says that y is equal to e to the power x. That is f of x. I'm sorry. F of x is equal to e to the power x. And g of x is equal to sine x. So the question is asking f of g of square root 2. So what is g of square root 2? G of square root 2 is sine square root 2. And what is f of sine square root 2? F of sine square root 2 is e to the power sine square root 2. So if you use your calculator to find e to the power sine square root 2, you will get your answer to be equal to 2.7. Fine. So I hope you're able to understand what I'm trying to say here, guys. Moving forward to the next one. This one says f of x is this and f of t is 0. So that means f of t is going to be equal to 4t minus 6, which is 0. That means 4t is 6. That means t is equal to 6 over 4, which is 3 over 2, which is 1.5. There you go. Easy ones, right? They're pretty easy. So this one says g of x is this and g of f of x is x. So that means what is g of x? That is 3 times f of x plus 2 is equal to x. That means 3 times f of x is equal to x minus 2. That means f of x is equal to x minus 2 over 3. Now the question is asking us the value of f of 2. F of 2 is going to be equal to 2 minus 2 over 3, which is going to be equal to 0 over 3, which is 0. Fine, guys. I hope you're able to understand what I'm trying to say here. Let's move forward. He says, what values must be excluded from the domain of this if f of x is there? So he says f of x is equal to 3x square minus 4x plus 1, and g of x is equal to 3x square minus 3. What is f over g of x? That is going to be equal to 3x square minus 4x plus 1 over 3x square uh, minus 3. Now what I can do is I can solve this quadratic equation. This will become 3x square minus 3x uh, minus x minus plus 1 over 3x square minus 3. So this is going to be, what I'm going to do is I'm actually going to take x out from here. Sorry, 3x out from here. I'm going to get x minus 1. I'm going to take negative 1 out from here. So negative 1 into x minus 1 over, I'm going to take 3 out from here. That is x squared minus 1. This is going to be, I'm going to take x minus 1 out. This is going to be x minus 1 into 3x minus 1 over 3. What is x square minus 1 square? That is x plus 1 into x minus 1. Now how did I get that? A square minus b square is equal to a plus b into a minus b. So I can clearly see x minus 1 and x minus 1 gets cancelled out. And you know what? I don't need to cancel out. The function remains the way it is. You don't need to cancel out. So from here, as you can see, x cannot be negative 1 and x cannot be 1. In both of these values, g of x will actually be equal to 0. You don't have to make g of x 0. So I apologize for dragging it so long. So the only way you can do this question is you can say that for f of x over g of x to be defined, g of x should not be 0. So when is g of x not equal to 0? So what you do is you take 3 out, that becomes x plus 1 into x minus 1. At x is equal to 1 and at x is equal to minus 1, g of x is going to be 0. That means x cannot be 1 or negative 1. So I hope you're able to understand what I'm trying to say here, guys. Let's move forward to the next part, that is this question here. So this one says that f of g of x is this, and so what do we have to find? We have to find f of g of x is equal to 4x square minus 8x, and f of x is equal to x square minus 4. F of x is x square minus 4. That means this can be treated like an input. So that is going to be equal to g of x whole square minus 4 is equal to 4x square minus 8x. That means g of x whole square is equal to 4x square minus 8x plus 4. Right, so that's there. So this is actually equal to 2x minus 2 whole square, because if you find 2x 2 minus whole square, that is going to be equal to a square plus b square minus 2ab. So that's equal to 2x minus 2. That means g of x is actually equal to 2x minus 2, and here is your answer. Pretty easy. Yeah, so let's see the next question. So this one says that f of x is equal to 4x minus 5 and g of x is equal to 3 to the power x. I have to find f of g of 2. What is g of 2? G of 2 is actually equal to 3 to the power 2, which is 9. Then what is f of 9? F of 9 is actually equal to 4 into 9 minus 5, which is 36 minus 5, which is equal to 31. There you go. Alright, so I hope you were able to understand. So what I'm going to do is I'm actually going to summarize what I did. So I started with functions. I explained what functions are, and for something to be a function, it has to pass the vertical line test. A vertical line test says that for every input there is going to be a unique output, right? So that is a vertical line test. Apart from that, then I also discussed about an even function and an odd function. How do you check whether function is an even function? If you replace x with negative x, the function remains the same. And how do you check whether it's an odd function? You replace x with negative x and y with negative y, the function should remain the same. A typical example here is y is equal to x cubed. The typical example here is y is equal to x squared. Then also we did the inverse of the function, which is very, very important. You just replace x with y. What you get is you get the inverse of the function. Another thing is that domain and range of the function is equivalent to the range and domain of the inverse. So that means the domain of the function is equal to the range of the inverse, and range of the function is equal to domain of the inverse. And geometrically, the inverse is the reflection of the function from the line y is equal to x. So geometrically, the inverse is the reflection of the function from the line y is equal to x. And then we also did some composite functions, that is f of g of x. This is something also known as fog of x, and g of f of x is something which is also known as cof of x, g of x, right? So thank you very much for watching this video, guys, and we're going to be completing this course, and you don't have to literally spend thousands of dollars trying to prep for just the subject test. We're going to be, we're going to be putting those videos onto this course, and we're going to be completing this course comprehensively. So this is just the first chapter. Just make sure that you give a visit to this website. You can find everything organized here. You can give us your valuable like on this Facebook page, and you can give us your valuable feedback at this email address. So thank you very much for watching this video, guys, and I hope you enjoyed it, and best of luck, and I'll see you in the next one.